Okay, this is the Laptop Pro, and most of the 3D scanner from Creality, it will come with a calibration board. You may think that all these calibration board are the same for all of the 3D scanner model, but in fact they are not. There are three types of calibration board for Creality laser scanner. This one is for Laptop Pro, and the Smooth S1 is a bit smaller, and this one in the middle is designed for Laptop X, and the one on the left here is designed for Smooth X1. The function of the calibration board is to maintain the accuracy of the 3D scanner, not the precision. Because these dots are spaced with the known distance, when you make calibration in the software, it's going to detect the space between the dots in a different distance from the surface and angle, usually 15 degrees angle on 4 sides. So when you use your 3D scanner for a while, you place it on the table, you knock it accidentally, just light tapping, it's going to move the component inside. It's going to slowly lose its accuracy. So you need to recalibrate at least once a month, or when the temperature is changed, because the internal component can expand. And all of the laser scanner that I know, it will calibrate to the refractive marker dots. This board will not help anything with the precision. Precision is made from the quality of the component inside the 3D scanner. And for the Smooth X1 is different. The structure inside of this scanner is made from die-cast aluminum. They lock the lens barrel and also the projectors with the sturdy structure. So you won't require to calibrate this scanner that much. Okay, these two boards are made from glass. The description just simply put calibration board. But if you look at the calibration board from the Laptop X, it's going to say high precision calibration board. So what's the difference? The material it has the same color. I think it's made from borosilicate glass, which has a lower thermal expansion than the window glass, about 3 times lower. They have to produce this in a very flat surface. But if you look at the marker dot, the one for the Laptop X is 7 millimeters, while the marker dot that used for the Laptop and the Smooth S1 is a regular 6 millimeters. And this marker sticker, I think they specially made with the highest precision than the normal marker. This is a normal marker, the refractive marker that's bundled with your scanner. Is 6 millimeters. This one is 7. So it's the same as the calibration board for the Smooth X1. Smooth X1 is the highest accurate 3D scanner from Creality. I've been testing it for 1 month without any calibration because they sent me the wrong board. They sent me this one, which is it's not working with the X1. X1 only works with this board, which is made from quartz. It's the same as this board, using a 7 millimeter marker dot, same size. But when you look in the back here, it's a quartz glass high precision calibration board. So this board could be very expensive. And the color, if you look at the color here, it has different color than the glass calibration board. Quartz has 6 times less thermal expansion than tempered glass. This is the most stable material. The one that comes with the X1 doesn't have this protective corner. So I test the X1 regularly. Without calibration, it still maintains the accuracy. Even though I use it quite a lot during the past month, I still get 10 microns of the accuracy error in the 7-line mode. With the Laptop X, I need to do the calibration more often than the X1. X1 also comes with the real-time calibration tools called the scale bar. So it will scale the markers that you place on the scanning scene to the known distance. I have tried this and I found that it reduced the accuracy because this bar is made from carbon fiber. Carbon fiber has a larger thermal expansion than the borosilicate glass, and especially the quartz. It's not improving any accuracy when I use the scale bar, but it might reduce the drifting error when I do a scan with a long travel distance. So I'm going to test this in another video by scanning a full car body. The travel distance could be 50 meters. Okay, this will be another 3 calibration board. This one from the MAF3. MAF3 is a high precision 3D scanner, but the calibration board it's not. It's made from plastic. The accuracy alert testing result for the MAF3 is not that good. And this one is for the Otter. I bought this Otter in the early batch, so the calibration board is made from plastic. It's not calibrated to the refractive markers because the Otter isn't made for tracking with the marker. It's an infrared 3D scanner. So most of the infrared and structured light 3D scanner will calibrate to specific geometry, and this one is polka dot, and it's the same for the Otter light, but Otter light is made from glass. It calibrates to a known distance of the polka dot. And for the MAF3, it's calibrated to a known distance of the checkerboard. So when you are using the Otter or the Otter light with the refractive marker, you're going to have less accuracy than tracking with the geometry because it was calibrated to the polka dot, not the refractive marker. So if you want the highest accuracy when you scan with the Otter and the Otter light, you should be using the geometry tracking mode. I have already tried and tested many times. It's almost as good as the Rapture if you place enough feature onto the scene. So when you require high accuracy when scanning with the Otter light, you need to add like a small chip like this. I have 2 colors, white and black, and it will give you a very low accuracy error. If you put this enough into the scene, make sure that it's not drifting during the scan. There's one thing strange about this scanner, Level Point Metro X. It's a laser scanner, but I use the polka dot calibration board. It gives like a 300 microns of the accuracy error, while other laser scanner from Creality only give less than 50 micron. This scanner is not calibrated at all in the laser mode. This is the calibration board for calibrating full field mode. In the full field mode, the Metro X will give higher accuracy than the laser mode. Many of the viewers ask me, how about the Metro Y? They have a new model. So I want you to look at the calibration board if they are still using the polka dot. This is not a laser scanner. This is the infrared scanner with the laser line capability. If it's a real laser scanner, it's going to be calibrated with the refractive marker dots. And this is 3D Maker Pro Mousse. This scanner doesn't come with a calibration board. It has only a single lens, and the spacing between the projector and the camera is very short, so that if they can make a sturdy frame inside, they don't need a calibration board. Accuracy error from this scanner is around 80 microns. Let's see what is the structure component. inside of this 3D scanner. And this scanner is still working. So yeah, let's try with a suction cup. Okay, mousse is made from die-cast aluminum. I can see the tool mark here. This will be the structural frame. This will be the infrared camera, RGB camera, and this one will be the projector. This will be a thermal pad. Yeah, it's still soft, good quality thermal pad, and it has no internal cooling fan. Let's see if I can remove the front cover. Okay, this will be the screw for the front cover. Okay, the front cover is removable. Let me unplug this. LED in front here. This will be the infrared camera, RGB camera. This will be the projector. The projector element could produce a lot of heat. That's why they put a thermal pad on the area where the projector is, and you can see that they put stiffener here to increase the sturdiness. This frame is made from die-cast aluminum as well. Let's see if I can remove this. My eye is not that good anymore. Let's see if I can remove it from the aluminum frame. They use adhesive to glue this. The 3D Maker Pro mousse teardown. I think it's 20-volt system. So look at the size of the wire. Okay, let's try to remove the board here. They use the same size of the screw. Okay. Inductance. I'm not an electrical expert. Can't tell you what is the chips for. Okay, they have another board here with a lip on, maybe connecting from the camera. Yeah, I can see it here. They have a small adjustment to adjust the angle of the projector to match the camera. They have a tools to do the adjustment in the lab. So after adjustment, if the structure is sturdy enough, it shouldn't move, so you don't need calibration for the entire lifespan of the 3D scanner. Probably the Samoon X1 will have this kind of structure as well, but for the Raptor and the Samoon S1, maybe they don't have this, because if the Creality put this kind of structure in the 3D scanner, they're going to show off in the advertisement. They did that with the X1. Okay, these three cameras, they have a thread so that you can adjust the height. I think it's locked with the glue. I can see the glue marking over the thread. They use this solid block just to lock the three lens together. That's why when I make a 3D scan with the mousse, when I scan a larger object, comparing with the other, the mousse has higher precision. The build quality of the internal component is very sturdy. This is a very well-made 3D scanner, and the tracking performance is good. It's not bad. Software is not as good as the Creality one, but the tracking performance is good. And the lens barrel is made from metal. It's not plastic, this is metal. Mousse and mousse light. The light version, I think it's not going to have this kind of build quality. This is Creality Scan 4 beta version 1.6. I need this version to be able to calibrate with the quartz calibration board. Okay, click on start. So the scanner will detect the known dimension from the marker with a different orientation and distance from the board. So that when it scans a real object, It's going to use this as a reference for the dimension. So it's 97%. Now the calibration process with the Creality Scan 4 is very easy. So you can calibrate as often as you need. It doesn't take a long time at all, especially if you're using the Laptor X. Comes with the high precision calibration board. So before you start to scan the critical component, the Laptor X cannot maintain its accuracy for a long period of time. Like the Smooth X1 can maintain the accuracy for over a month without recalibration. Alright, thanks you guys for watching. I'll see you in the next video.